Okay, so today we're going to take a look at problem 19 of the 2019 AMC10 A. And basically we see that it asks for the least possible value of x plus 1 times x plus 2 times x plus 3 times x plus 4. And then we add 2019 at the end of this expression. And so we can do some observations first. For example, we see that this expression is very difficult to manipulate, and the characteristics of this polynomial are going to be somewhat difficult to determine directly, and the answer choices don't really help us because they're all very close to each other. However, if we just take a look at this part of the expression, it's a polynomial expression which we can easily determine the characteristics of because we easily see the distinct roots of this polynomial. And our first idea is going to be to graph this. So of course it has a root at x equals -1, x equals -2, x equals -3, and x equals -4. So now, if we take a very large value of x, for example, maybe 100,000, we see that this expression right here is going to be positive. So for a very large value of x, y is going to be positive. And of course, at x equals -1, y is going to be 0. So we draw it all the way down here, and it goes down, and up. Actually, if we observe closely, this function is going to be symmetrical. And now what we can do, since it's symmetrical, we can estimate the values of x for which the function has a global minimum, and we see by this graph that it should be somewhere between -2 and -1, or somewhere between -4 and -3. So we can take -2 and -1, for example, and we can take its midpoint, which is at x equals -3/2. This is just an estimation, however, so be aware that the answer may not be completely accurate, but will be sufficiently close to our actual answer. And if we basically plug 3/2 back into this original expression, I'm going to delete this for now. And if we take x equals -3/2, this expression is going to be like this part. It's going to be -15/16. Of course, we need to add 2019 at the end, because to get from this expression to this entire expression, it's going to be transformed by the vector 0, 2019. And so if we add 2019 to -15/16, it's going to be approximately 2018. And the closest value is 2018, which is choice B, and that is our answer. However, there is a more precise way to do this. So if we write the expression again, so some people might feel tempted to be like, determine the minimal possible value of an expression with x in it, and then add basically a constant number to it. And that basically uses the trivial inequality, which states that the square of any real number is going to be a non-negative number, so basically equal to or greater than 0. And so we attempt to construct a square number right here. So first, because we have a quartic equation, which is very hard to manipulate, so we can group this as in this format. And if we group it like this, we have x plus 1 times x plus 4, and this is multiplied by x plus 2. I'm going to put this in brackets so it's going to be clearer, and then plus 2019. So what we see here is this becomes x squared plus 5x plus 4, and multiplied by what is this? It's x squared plus 5x plus 6, and then finally plus 2019. And if we do some more transformations, we see that this is plus 4, and this part is plus 6 right here, and they differ by 2. So this makes us think of the difference of, well, like, difference of squares. Yeah, sorry. And if we arrange this, so it becomes x squared plus 5x plus 5. And then this is minus 1 because it's actually 4. And then this expression right here is going to be x squared plus 5x plus 5. However, now it's plus 1 because in reality it's plus 6. Then we add 2019 to the very end right here. And by difference of squares, we see that this is actually x squared plus 5x plus 5 squared minus 1 squared, and then plus 2019, which is going to be the same as x squared plus 5x plus 5 squared, then plus 2018. And now we just need to confirm that this expression right here has a real root for when it equals 0. So if we take b squared minus 4a times c, we see that it is actually 25 minus 4 times 5, which is greater than 0. So that means this expression has two real roots, and we're basically two zeros, and it means that we can have this expression to be 0, which is its minimal value, and for this value we can evaluate 2018 plus 0, which is going to be equal to 2018, which is still our answer choice B right here. Of course, there are going to be many other ways to do this. For example, if you use calculus, if you really want to use it, you can basically solve it instantly, but it just makes the problem less fun to do. So yeah. Okay, thank you guys. Bye.